Hi everyone, Xian and I will be presenting our network design for medium wave broadcast, a company with several departments across different locations. As you can see, medium wave broadcast has departments like administration, newsroom, and marketing. Each required reliable network for connect their device and share information efficiently. Administration department number of hosts required is 255, and newsroom department is 227, production department is 206. About location B, marketing department is 187, human resource department is 155, and engineering department is 157. And about location C is international news department, but I separate with international news department become with 2 because it's 2 different subnet, but its connect is 1 router. So number of hosts required is 190. So next one is addressing design and subnetting table that we do. About this, to ensure efficiently use IP address, we design a private network using the address range 10.0.0 until 10.255.255.252.0. We employ a technique called variable length subnet mask, which is VISM, to create subnet with different size. This allows us to allocate IP address more efficiently based on the number of devices in each department, similar to how neighborhoods within a city are sized efficiently. We also consider host growth table, before growth table, and after growth subnet table. The network can handle 120% increase in device. This ensures scalability for medium wave broad cluster evolving needs. So this one is a host growth table. For location A, at the ground floor, is the production department. The number of hosts required is 255, that as last time that's showing just now. So a number of hands for 134% growth equals 1.2, and the total number of hosts needed calculation is 255 times 1.2 equals to 202.4, plus the number of hosts required, which is 255, and the total is become 555. And the first floor is newsroom department. The number of hosts required is 257, and the number of hands for 1.2 growth times 1.2 equals to 272.4. And total number of hosts needed is 499. And the second is administration department, 206 times 1.2 equals to 247.2, plus together is equals to 454. About the location B, ground floor, is engineering department. Number of hosts required is 187, and times 1.2 equals to 224.4, and plus together is 412. And the first one is human resource department, 155 times 1.2 equals to 186, and plus together equals to 341. And the second one is marketing department, 137 times 1.2 equals to 164.4, plus together is 302. About the location C is, as I said just now, is international newsroom department. They separate with 2 subnet and connected with 1 router, so I just separate with A and B. And the number of hosts required is 190, and times 1.2 equals to 148.8, and total number of hosts needed is 262. And next one is before growth subnet table. For example, subnet number 1, production department, which is in location A. The number of hosts required is 252, and the maximum host is 134, and the network address is 10.0.0.0. Before the growth, the class B/23 is already can handle the whole things. So the first usable host is 10.0.0.1, and the last usable is 10.0.0.254. Broadcast address is 10.0.0.0.255, and the range of address is 10.0.0.0 until 10.0.0.255. The usable IP is 10,022, which is maximum host 10,024 is minus with 2 because we need to leave empty the end and the first one for the IPs. The network address we're using is times 4 times 4 times 4 times 4. As you can see, all the usable IP is all the same, and the CIDR is all the same, and the network address is just like times 4 times 4. The first one is location A, 10.0.0.0.0 times 4 is because to become to 10.0.4.0, and times 4 again plus 4 again is 8, and plus 4 again is 12, and plus 4 again is 16, and plus 4 again is 20, and plus 4 again is 24. So as you can see, it's the number of hosts required, and is a question given as CIDR. The next one is after growth. After growth, right, we're changing a number from 255 become to 555. How we do it? And we're using the calculation. So times 1.2 equals to 555, and we're using this one is after the growth. So after the growth, we cannot using the slash 23 again. So already, so we just change it to slash 22, and yeah, the whole thing is the same. We're just changing the number of hosts required and the CIDR. So that's all about me.
Hello everyone, my name is Xian. We have received a requirement from a company called Mediawave Broadcaster to ask us to design a network topology design to them. So here is the network topology, which is follow the requirement of the company to design. So here you can see that we use two router on this topology. The reason why we use two router is because to transfer the data to the other location can be more stable and more faster. And then each of the subnet need to increase 0.0.4.0, which is plus 4 plus 4 plus 4. So here is the whole explanation of the topology, and then I will show out the process of the transfer data to make sure that it can work or not. So example, like I use administration department PC to transfer the data to the location B, which is human resource department PC. So as I say, the PC is 10.0.16.2. So I need to ping the location on the command. So here need to spend some time to process the data transfer. So we need to wait. Okay, as you can see here is 50% loss, but it's okay, it's normal thing. So we need to reinsert the command again. Then the conclusion of this data transfer process is success, which is 0% loss. So I shows another sum of the sample to on this explanation. So like I need to transfer the data to other location, which is C location. So the C location PC is 10.0.24.2. So then continue to reinsert the command. Then is success to transfer the data. So now I want to transfer the data to A or B, which is use the location C PC. So I insert the Seng command at here. Okay, there's no problem on this transfer data, and then transfer the data to locations B. 10.0. Okay, there's no problem on here. Then we continue to use location B PC to transfer the data to A or C. Okay, there's also no problem on here. And then transfer the data to the location C. Okay, so it means that the whole topology to transfer the data is no problem. So that's all of the presentation. Thank you everyone.